Hi. Hello. It's Mrs. Eberly. Of course. We are going to do some work with what we worked on in class, which is scientific notation. And remember, scientific notation is used because there are some humongo numbers out there. And there are some super duper small numbers that instead of writing all those zeros, we can condense it down into that small form of, remember this from class, something times, what numbers am I going to write next? Well, it's actually just a number, and that number is always the same. It's a 10 to the something power. So remembering that this number here needs to be 1 or more, but less than 10. And this number here needs to be an integer, which means it needs to be a whole number, or a whole number's opposite, or maybe 0. Okay? All right, so let's try some of these things. And I do want to say, because I saw it in class, is that we do actually use the x for times when we're doing scientific notation. A lot of you in class were using the dot, and yes, that represents multiplication, but typically, always, you'll see the x being used as a multiplication sign. Okay, so try to use that. All right, so let's start in. Let's go through some examples together. So let's start with something like 75 million. And that was what my paycheck was just last month. Weird. Oh, did I say that was in my dreams? Yeah. So if we're changing this to scientific notation, it's going to look something like this, right? And I'm just going to fill in the blanks. So I need to get this number to be 1 or more, but less than 10. So the decimal's here right now. If I move it one spot, it's definitely not good. So I need to keep moving it until I get to a number that's between 1 and 10. So 75. No, 75, not going to be good. That's not between 1 and 10. So if I move it here, 7.5, would that be between 1 and 10? Yes, it would. So I'm going to choose 7.5. Okay? And then from there, I need to fill in one more thing from my scientific notation form. I need to get that exponent. So the exponent tells me how many times do I want to multiply this 7.5 by 10 in order to get back to this big number of 75 million. Well, how many spots do we move that decimal? Well, I moved it 3, 6, and then around the 5 to be 7 times. Okay, so what this, there it is, we got it. But what that actually means is that if I take this number written correctly in scientific notation, and I go back to the original number, this is how I do it. I take 7.5 and I'd multiply it by 10. And what is that going to equal? Well, if I multiply by 10, it just moves the decimal one spot. And I get it to be 75. But the thing is, we need to multiply it by 10 7 times. So now I'm going to take 75 and multiply it by 10. And now I'm at 750 because the decimal has moved yet again. And then I'm going to do 750 and multiply that by 10. And then I'm at 7,500. So all that's happening is the 0 is being added on. And how many times are we multiplying by 10? 7 times. Meaning from 7.5, that decimal is going to move 7 spots in the bigger direction to get back to our original number of 75 million. All right, let's try another one. Okay, let's go with, let's get a number that's already written in scientific notation, like 8.21 times 10 to the 5th power. And we want to write it in what's called standard form. So we want what the original number was. Okay, but of course in mathematics there's a more technical term, and that's called standard form. All right, so we work with 8.21 and we ask ourselves, okay, which way are we going to go with that decimal? If we go right, the number is going to become bigger because we went to 82 instead of 8. If we go left, the number is going to become smaller. So how do I tell which way to go? Well, that's by looking at this 5. The 5 is positive, meaning that my original number is supposed to be a big number, meaning that I'm going to move that decimal to make 8.21 bigger. So I'm going to move it to the right, 1, 2, and then I still have to go 3 more to get 5, so I'm going to add on 3 zeros. That's how I do it. And now I'm going to rewrite the number without my little squiggly lines as 821,000. All right, let's try one that is a little different. So let's say we have a number like 0.0084. Super duper small. I mean, that could be rounded to maybe 1 penny because of right here. That 8 would kick up that 0 to 1. So this is barely even a penny. Okay? If we're writing it in scientific notation, boom, boom, times 10 to the boom, I now need to move that decimal to make it between 1 and 10. So if I move it here, are we good? No. If we go here, we're at 0.84, which is close to 1, but it's not 1 or more. So I need to move it 1 more spot, and I'm at 8.4 times 10, and now I need to figure out this number. We moved the decimal 3 times. The thing is, our original number was small, itty bitty. Remember, barely even a penny. So it's going to be a -3. And there we have it. That number is now in scientific notation. And yet again, for the people who have some working brains, this means that I'm taking 8.4 and I'm not multiplying it by 10. I'm actually dividing. When I multiply by a power of 10 that is negative, it means I am dividing by 10. So I'm dividing by not just 1 10, not 2 10s, but 3 10s, which just means the decimal is going to move to make this smaller by 3 spots, which leads me back to my original number of 0.0084. Going in circles! All right, so last one. Let's say I give you a number like 2.005 times 10 to the -2nd. It's already in scientific notation. What am I going to say? Write it in standard form. So I'm going to have to take 2.005 and move that decimal this many times, twice. Since it is negative, means I need to make it smaller. So if I move it to the right, no, that's not going to help. That'll become bigger. So I'm going to go 1 spot, 2 spots, meaning I need to add in a 0. And I do not like how this looks, so I would rewrite it because I am not really sure what you're saying there. So the number is really 0.02005. Scientific notation yet again. Thank you for listening.